Hello again. Welcome everybody and thanks for joining us today. I'm your host, Doug Denny, the Director of Technical Marketing for the Dedicated Infrastructure Business Unit here at Rackspace. And we are hosting a deep dive today to talk about architecting for failure and resilience on Amazon Web Services. We host these deep dive hangout sessions on the second, third, and fourth Wednesday of every month. And in each session, we like to talk about real-world topics geared for practitioners that often involve things like reference architectures of reports or white papers that are derivative of the work we do for customers or the lessons we've learned along the way. In each deep dive series, we like to talk about a specific asset and then have conversations that support the topics covered in that asset. In this case, it is a white paper. And all of these architectures or white papers or documents can be found at rackspace.com/deep dive, as well as our past library of sessions that we've aired over the previous months. If you're watching live and you have questions, please use the Google Hangout Q&A feature and get them over to us, and we'll make sure toward the back half of the show that we answer all the questions that get submitted along the way. And also, if you're watching on demand on the landing page or on YouTube, just email us at customercare@rackspace.com if you have any questions, and those go to me and my team, and we'll make sure we get them routed to the experts who can help you get you answers to your questions. So with that out of the way, I will start and first introduce our guests. We've first got Kim King, who has to leave early, by the way. So I'm introducing Kim first. But hey, Kim, thanks for joining us today. How are you doing?
Hi, thanks for having us. I'm doing great. How are you doing?
Doing great, doing great. And tell the viewers a little bit about what you do for Rackspace.
I am a product marketing manager for the Fanatical Support for AWS business unit. So I am responsible for working with the product team to develop all of the content to keep you guys informed on our offer.
Awesome. Well, thanks for being here today. And I know early on, because you have to go, we're going to have you do a brief overview of Fanatical Support for AWS at Rackspace. So we'll jump into that here in a second. And then also from Rackspace, we have Jerry Hargrove. Hi, Jerry. How are you?
I'm doing good, Doug. Thanks for having me.
Great to have you as well. I know you guys are busy, so tell us a bit about what you do for Rackspace.
Sure. I'm a solutions architect on the same team with Kim on the Fanatical Support for AWS team. I work with Rackspace customers who are moving to AWS or migrating to AWS and help with them to build out architectures and systems on AWS that are highly available and fault tolerant and scalable and take advantages of the services and features that AWS provides.
Awesome. And I'm excited about today's show too, because I work in the Dedicated Infrastructure Business Unit, and when we started up this show, we originally focused on dedicated infrastructure topics, and we've since expanded the program. We're now reaching out to other business units like you guys, and it's great because there's a whole bunch of stuff that we would have liked to have covered in other but now we actually get to. So I really appreciate you guys joining and bringing this content to our viewers. So. Real quick, I'm just going to go over the topics that we're going to cover today. So first, we're going to do a brief overview of Fanatical Support for AWS, or FAS, at Rackspace with Kim. And then we're going to have a multi-part discussion about architecting applications for availability on Amazon Web Services. So this will cover things like topics around fault tolerance, infrastructure redundancy, and the automation required to make use of all these things, right? And all of this discussion is supported by a white paper called Architecture on AWS, 3 Commonly Missed Best Practices that the viewers can download by submitting the form that they should see as they're watching the show. So does that sound good to everyone?
Sounds great.
Awesome. Okay, let's dive in. Well, again, since you have to go soon, Kim, we'll start with you. Can you just give the viewers a brief overview of FAS here at Rackspace, what that offering is for customers?
Of course. So many businesses are wanting to make the move to AWS, but they don't want to have to deal with the day-to-day operations, managing it themselves. So in order to make that move, they need technical expertise on the AWS platform to migrate their workloads to AWS. They need to build an AWS environment according to best practices. They want to make sure their environment is scalable and secure, but will also evolve as the needs of their businesses change. They want help meeting their governance and compliance needs, 24/7 operational support, but they don't want to hire all of the staff and expertise required to do it on their own. So Fanatical Support for AWS helps businesses that are experiencing these issues by combining tooling and automation for AWS with over 320 AWS certified engineers and architects that deliver Fanatical Support for the customer's AWS environments 24 hours a day, 7 days a week, 365 days a year. So that is Fanatical Support for AWS in a nutshell.
Very cool. Thanks for that. So it sounds to me like, I mean, this is a very common pattern that we apply here at Rackspace, which is that there's different sort of paradigms for technology. Integrating all these things together generally proves to be a hard exercise for companies large and small, and we supply experts. So whether that's the old world integrating SANs and physical servers and traditional relational database software, making all those things work together, it sounds like you guys are doing the same thing for all the constructs that AWS provides, right? AWS has all these different services, and there's a million different ways to solve a problem in AWS, and really it's having the experts available to help you pick the cleanest, shortest path through all these choices is the goal, right? Is that a fair recap?
Exactly. Yep. And this is in line with Rackspace's core competency for over 15 years of developing expertise around the technologies that our customers need the most. So Fanatical Support for AWS is definitely an extension of that competency.
Awesome. Well, thanks for that. It's good to sort of tee that up, because I know that we'll have a lot of viewers that we still see this today. People are still learning about the fact that we are now supporting customers that operate on Amazon Web Services. So it's always great to sort of reinforce that message. And folks that are interested in more information, obviously there's resources on our website. But I know recently our buddies over at the Cloud Office Hours, Alan and Drew Cox, have done at least one, potentially more shows with some folks from the FOSS group who went into more detail about the offering as well. So anyone who really wants to learn more can go check out the Cloud Office Hours show as well and take a look at some of the content. Well, all right, Kim. Well, thanks so much. Do you if you need to run, you can go for it. I'll take it from here with Jerry.
Thanks. You're in good hands.
Excellent. All right. So speaking of experts, right, that work here at Rackspace to help us with customers, we've got Jerry, and let's go ahead and dive in. I broke this up into like a few different buckets, right? When we were putting the notes together, and I started with the topic of fault tolerance, right? So let's sort of unpack fault tolerance for the next few minutes and talk about what that means in the world of AWS. What does it mean to be fault tolerant? Help me with that.
Yeah, so one of the ways I like to think about fault tolerance is if you've ever seen the movie Toy Story with Woody and Buzz Lightyear, there's a scene there where Buzz shows how he can fly, and he jumps off a bedpost and he flips out his wings, bounces off a ball, eventually gets stuck on a toy airplane that flies him around. And when all is said and done, he lands back on the bed, and Woody turns to him and says, "Well, that's really not that's not flying. That's falling with style." And so I like to think of fault tolerance and failure resistance in those terms. It's failing with style. When we fail in the cloud, we have the infrastructure and the bits and pieces together that allow us to do that gracefully, and allow us to do that such that our failure in the cloud can almost be virtually indistinguishable from success. So we have all of these tools and mechanisms in place that allow us to fail, to degrade our service, but not necessarily just drop off the edge of the world.
Sure.
One of the things that, if listeners have been with AWS or been or watched videos or been to AWS summits or the reInvent conference, one of the things that you'll always hear from Werner Vogels, who's the Amazon CTO, is that everything fails all the time, and that's really one of the points that I want to bring home today and throughout this discussion, is that regardless of whether you're in AWS or you're in an on-prem environment or you're running this out of your garage, your application, at some point everything is going to fail. And that's really the root of being fault tolerant or fault resistant or resilient, is understanding that and making sure we have at least thought about failure from the very beginning.
Okay.
And I want to, and again, if you've been with AWS, for the last 10 years or so, there have been AWS outages, and very often after some form of AWS outage, you'll hear from all of the different AWS customers who have experienced some sort of outage. You'll see them on blogs, you'll see them on Reddit talking about their outage, how it was AWS's fault. One thing to keep in mind, though, are all of those services and companies that you don't hear from who are running on AWS after an outage. Those are the ones that we want to model and really think about. We don't hear about them because they're fault tolerant or perhaps fault resistant.
Right. And AWS gives you a lot of, again, the constructs needed to deal with that inevitable reality, but whether or not you choose to make use of them is ultimately your choice, right? And okay, and okay, great. Well, then let's take this down a notch into more concrete terms. Like, give me help, like, draw a picture of like an application, right?
Yeah.
How that works.
Definitely. It's useful to think about this in concrete terms. So I like to start with just a simple application. For example, suppose we have a simple application that we're building. Maybe it's some sort of social application. In this case, maybe we're doing a catering application, and we're allowing users to log in. There's a web interface. There's it's a front end. Maybe it's a simple LAMP stack. There's some business logic in the middle that handles or taking orders, processing payments, and then ultimately delivering the product, the food, whatever it may be, to the end customer. A lot of times this might start out as a single monolithic system. It's some garage project that a startup has started, and they've only got one system, so they're doing it there. Maybe some of the components have been broken out. In this case, maybe there's some cool semantic analysis engine that does recommendations. But in any case, it's a very simple system. It's got a front end, it's got some business logic, and perhaps a database back end. And I think thinking in terms of fault tolerance, it's using that as a reference point, and then maybe we'll refer back to it as we go through the discussion and talk about how different strategies might apply to that simple application.
Okay, great. Great. Okay, so that's our reference application, and then so when we think about having a discussion about let's say this customer brings this application, and you want to have a discussion about fault tolerance and the customer's goals, right? How do you approach that conversation with the customer? How do you start peeling back the layers of the onion?
So I like to think about it in a couple of different layers of that onion. The first is really at the application level. So when we're talking about fault tolerance, how can you make your application itself more fault tolerant? How are there any changes that you might need to make to your application that make it more resilient? What are some good characteristics of applications that make them more fault tolerant and more resilient? What are some things that you can do when you're building your applications to prepare yourself for that type of environment where you think things are going to fail, whether they be downstream dependencies or failures on the local system that you're running? Another layer that I really like to think about is fault tolerance at the infrastructure level. So specifically here, we're talking about AWS. What AWS services and features can we take advantage of when we move our application from wherever it is, from our garage or from our on-prem data center to AWS, to the cloud? What are some of the things that we can use there to make ourselves more resilient and more fault tolerant? And a third thing that we usually talk about is, so operationally, how can we be more fault tolerant? So, and this comes down to a lot of times around people and automation and just processes, but that's really a third tier that we go into. I wanted to make the point at some point that a lot of these things we're talking about aren't specific to AWS. As you mentioned earlier, depending on who we're talking to, whether it's AWS or some other cloud provider like Azure or Google or public cloud, these same principles apply regardless.
Sure.
Today we're going to be talking specifically about AWS services and features that can be applied, but you can find similar mechanisms in other areas.
Okay, yeah, I think that's a good point too to make, right? Because these are principles that are universal, but again, from provider to provider, the tools that make available to you will vary in features and capabilities. So, okay, well, good. Well, then let's jump into a bit of the infrastructure redundancy concept, right?
Sure.
So, what things does AWS make available to sort of for customers to make use of at the infrastructure level?
So one of the first things that we want to think about is just what features and service AWS provides, and a lot of times that comes in. We think about fault tolerance in general. We think about redundancy, and redundancy. I mean, that's fairly intuitive, right? If you have one web server, how do you make that system more fault tolerant? Well, you add another web server, right? That's pretty straightforward, and there's no new news there. And we can continue that pattern out, so the N+1 pattern, right, where you have some capacity need N, and so in order to compensate for some type of failure or improve your fault tolerance, you go to N+1. And the larger N is, usually that means the more economical your solution is. And we can somehow determine what N is by what the rate of failure of the underlying infrastructure is. So that's usually the most common approach initially, is just to apply some redundancy to it. And in AWS, when we apply redundancy, obviously we can spin up new EC2 instances on AWS. But there's some other features and services that are available on AWS that allow us to do that more easily. And just to name a few of them, starting at the very base level. So if, say, for example, you did want to have 2 instances instead of 1, you'd need some way of replicating one instance and making it 2 or 3 or N. And we start at the very basics with Amazon Machine Images. So AMIs, as we call them, are images that are provided by Amazon or partners of Amazon or other customers of Amazon that include common base infrastructure like operating system, commonly used libraries, commonly used application frameworks, depending on where you get them. But we use those as sort of the basis. So whenever something fails, we know, okay, we just need to go grab this other image and start up another instance using that. So, in the case where you just had a single instance running and it failed, you would go start up another one using that same image. It would start back up and start doing the job again. So we need those as sort of the base tool for doing any type of redundancy. And underlying that, there are other components. Disk storage, for example, Amazon provides elastic block storage, which is a block storage mechanism that we use. And you can think of it as disk storage. That's what it's most commonly used for, as the hard drive or the operating system drive or the data tier on these instances. It's good for file systems, database, that sort of thing. But it is another way of helping you to replicate your environment. So now I have this underlying disk system that can be transferred between different instances. If an instance fails in AWS, it could simply be a matter of starting another instance and attaching the same drive to it, and off it goes. Another very commonly used tool when we talk about redundancy in AWS are elastic IP addresses. So for example, I have an application that's running that has exposed itself through the world, or to the world, through an IP address. If that instance fails, I want to be able to very somewhat transparently switch out the underlying infrastructure without the customer really experiencing it. And
Sure.
so I can use elastic IP. Elastic IPs allow you to detach an IP from one EC2 instance running on AWS and move it to another EC2 instance running on AWS. Another thing to think about in AWS, and this goes more into just sort of the general framework that AWS provides, but again, we're talking about redundancy, and that is the use of availability zones in AWS and regions. And for users who may not be or for listeners who may not be too familiar, I'll just give a brief overview of those regions. AWS is broken out into regions around the world. There are several in the U.S., Virginia, Northern California, Oregon. There are others around the world: Ireland, Dublin, Tokyo, Singapore. And those are available. So if you need global redundancy, you can use those and spread your application around the world doing that. Within each region, though, AWS provides what they call availability zones. And availability zones, sometimes it's useful to think of those as individual discrete data centers. So say, for example, the AWS region located in Oregon is composed of 3 availability zones. What that means is that within that region, there are 3 data centers, if you will, that are that compose this region. They are located in perhaps different buildings using different power supplies in different fault planes, different fault zones, different flood plains, for example, so that they're fairly independent of one another, but they're connected through very high-speed connections, so that you can consider them almost as one region. And so those are some of the fundamental tools that we might use when we're thinking about fault tolerance on AWS. All of those are used to improve our ability to be resilient in the case of failure. So if you say in our sample application we were thinking of, if we have redundant systems running our web server, then if that instance fails, we can bring another one up in its place. If we have multiple instances running and we want to put those in multiple availability zones, if there was an availability zone failure, then we still have some infrastructure up and running. Again, thinking back to that quote, everything fails all the time. At some point, every one of those pieces will fail, and so we need to be ready for it.
Sure. Yeah. No. This is helpful, and it sounds to me too like there's a spectrum of tools, right, that are available for problems of different sizes, right? So if I'm a bank teller and I work at a bank, I probably don't need to spend the money to armor my personal car, right? but so that would be overkill. I wouldn't necessarily make use of like multi-region deployments if I have very simple needs, right? But if I was, say, let's say I worked in a different side of the bank and I transferred money a lot and I was a high-profile figure, then I might take those steps, right? Just like if I might armor my car. But if this is a terrible analogy, by the way, but just go with it. But if there's a significant business impact to being unavailable, right, or people, it's a system that like people's lives are on, right? Then you have a different set of tools that you might lean toward depending on the severity of the situation that one faces with downtime. Is that a fair statement?
Yeah, it definitely is, and it's one of the discussions that we have with AWS customers that we're working with is what are your requirements? What level? Fault tolerance and availability often go hand in hand, and so we discuss them in those terms. What are your availability requirements? What level of fault tolerance do you need? Because when we're looking at solutions for customers that we're working with, we use that to sort of lead us in the right direction. And you're right, for our sample application where we're catering food, we're not talking about people's lives here. So maybe a 5-minute outage is okay, or a 15-minute outage is okay. We want to understand that, and we want to build our systems around that, so that in their own respect, but that tolerance level is subjective. It's based on the customer and their application and the level of availability and tolerance that they need.
Very cool. And then I have to call something out. In the notes, there's something about the first rule of AWS Fight Club. Can you explain that to me?
Yeah, so the first rule of AWS Fight Clubs, if you've seen the movie, you know the reference. But in this case, it's really a reminder to myself that anytime we're looking at AWS and when I'm making recommendations to customers about what services to use, and there's this whole gamut of services on AWS, from completely managed services to basic building blocks like EBS volumes, for example, for disk storage, or EC2 instances. So you can choose to build out your infrastructure using EC2 instances. A good example of that is I want to run a database and I want it to be highly available. Well, I can certainly start up several EC2 instances and configure them in a highly available manner using MySQL or Maria. I can mirror, I can do log shipping depending on the database to make sure that I have some redundancy into my system and I can automate failover. Mm-hmm. Or I could simply use Amazon's relational database service, which is a managed database service, which does all of that for you behind the scenes. And so the first rule of the AWS Fight Club for me is always use AWS managed services when you can. Because, I mean, in the end, when your customers look at your application, they really aren't concerned with how your infrastructure is being built out. They're really concerned with your product. And what differentiates you from your competitor probably isn't the infrastructure that you're using, it's your product. And so anytime you can use AWS services that are managed by AWS as opposed to self-managing them yourself, that means that you can spend more time on your application, or you can spend you can reduce cost on infrastructure around that and put it somewhere else. So that's really the rule, is always use those managed services whenever you can and to the extent you can.
That makes sense, and I think that's also a good segue, because the next question is taking advantage of infrastructure or redundancy features native to the infrastructure. That still doesn't necessarily spare you from, in every case, from having to make application level changes. Right? Sometimes it does, sometimes it doesn't. And so knowing that there's a cost attached to that in man hours or learning time is just something to be aware of if you choose not to use the infrastructure that AWS provides you and sort of reinvent the wheel. So you have to factor in those soft costs as well. But back to the question then, so like, does redundancy at the infrastructure layer require application level changes? When does it not?
That's a good question, and like many answers on AWS, the answer is really it depends.
Sure.
Because everybody has different needs. I mean, if you can imagine a very simple static website that there's really not a whole lot of business logic in it, there's not a lot of dynamic content to it, then you may be able to move that to AWS and scale it out very easily and add fault tolerance to it with very little change to it. But a lot of times it comes down to thinking about your application, and a real good use case, or a real good discussion point for this is state. So where does your application store state? So thinking about our simple reference application, it's got a web front end. Users log in and they make orders. The system stores information about that user. It stores information about their preferences, and stores information about the session when they log in. So in a case where we're talking about, just generally on AWS, when we're thinking about availability and scalability and fault tolerance, what that really means is we need elastic systems. And in elastic systems, pieces come and go depending on the current demand and the current need. Or in the case of failure, an EC2 instance may simply drop out of existence. Keeping in mind that EC2 instances are virtual machines that are running on actual hardware somewhere, and at some point that hardware that they're running on could experience a failure, could have a power supply outage or a memory failure. Those things happen just like they do in the real world. And so we need to be aware of that and resilient to those. So at any point, a particular instance could drop out. And so you need to think about what information is stored on that instance and what would be the impact if that instance failed. In the simple case of a web application, that might mean that their session information is lost. And so in this case, worst case, say for example they're behind a load balancer. If an instance fails, they would then have to go back out, re-authenticate, log in, and be shuttled off to another instance. So ideally in that case, we're storing that instant or that session information about that user, about their login somewhere else. And so having knowledge of where that information is stored and what you're going to do with it can really determine the level of changes that you require. And then further down the pipe, as we think about other techniques and mechanisms for making our systems more fault tolerant. It may require changes to the application around, database locations, whether we're reading or writing, have we moved data around in the system to make it more fault tolerant. Those are some of the things that we want to think about. Also, in terms of the application itself, how can we decompose it into its component parts? So, for example, if this was just a single monolithic application that we had moved over to AWS, we just had an application, we just lifted and shifted, we forklifted it over to AWS, well, that's just one big single point of failure to me.
Sure.
And so if any part of that application, and in our case it could be the web front end, it could be the order processing system, the payment processing system, the delivery system, the preferences engine, if any part of that fails, then it could bring the entire system down. So thinking about it from an architectural perspective, how could we decompose this into component parts? How could we make it more of a service-oriented architecture or microarchitecture, such that individual failures don't necessarily impact the entire system? Those can drive changes in the application.
Okay. Okay, great. Thanks for expanding upon that, because I think that I in my old and past lives too, I saw a lot of customers that were like, I have an app in this data center and I want to drop it into the cloud and then I want the magic to happen, right? And I think those days generally are long behind us. Like, most people understand the foundations of moving an app to the cloud, but you never know, right? Like, it's always good to sort of like resync expectations, because you can do that, but the benefits aren't really available to you when that's the only step you make, right? And so we always would help customers like understand how they push their application to take advantage of more of the native features of a cloud platform for infrastructure. And I think this gives way to the next section, which is all about this idea of automation, right? So you have, let's say, when provided with these constructs for dealing with events and failure, well, you still have to take action, right? So how can you do that in a way that gives you like cloud-like results, right? And so let's start picking this apart. So where does automation fit into this picture between the application and infrastructure and everything else?
So I like to think about it, if you've ever been in a development environment or in a DevOps environment where you've worn a pager. The pager always goes off at 3 o'clock in the morning, usually on a Sunday morning, and I mean, honestly, birthday. Yeah, exactly. And I mean, honestly, that's not my best hour. I'm not thinking straight at 3 o'clock in the morning, regardless of what I did the night before. Even if I stayed home, I'm not at my best. And so at 3 o'clock in the morning, my pager goes off. I get online. I triage the problem. Turns out something has failed, and I need to take some manual steps to recover it. There's a huge amount of room for error there, and we introduce a lot of times more problems than necessary. And so, I mean, and again, this is not specific to AWS, but just in general, that anytime we can automate any of these processes, we want to. And specific to AWS provides such a variety of services and features that allow us to do this that it actually makes it very, very painless. So in thinking about it in terms of fault tolerance and scalability, suppose we have our payment processing system that sits in the background and it's just watching for new orders to come in, and then it takes those and processes them, does it whatever processing it needs to do to collect the money from the customer. What we want is for that system to always be up, and we want it, and we also want it not only to be fault tolerant, such that if something happened and it failed, that it would resurrect itself and go on processing payments. We'd also like it to be automatically scalable, so that if all of a sudden there was an uptick in business, someone didn't have to go in and manually provision instances. And so AWS provides a lot of services built around that. One of those is called auto-scaling groups. And so auto-scaling groups allow you to build out this infrastructure that says, essentially, I have this instance, here's a machine image associated with it. If that instance ever fails, bring another one back up in its place using that same instance. So now we have sort of this self-healing mechanism where an instance can fail and it will automatically bring one up in its place. We can also configure it to say, I want you to always keep 2 of these up and running at any one time, and I want you to place them in different availability zones for redundancy. Mm-hmm. And if demand dictates, I want you to add more. So we can establish metrics around our application that say if orders are coming in at this rate and it increases to this rate over time, go ahead and start adding additional payment instances in the background to continue handling that and scaling it out. So those allow us to automate that process of scaling out our infrastructure. We can also use elastic load balancers. So in the case of our web front end, we have a load balancer in front of it. In this case, it's an elastic load balancer provided by AWS. Using that in combination with an auto-scaling group is actually very powerful. Now you have a web farm that's processing requests that, because it's in an auto-scaling group, can automatically recover failed instances and grow and shrink very elastically over time. And it automates the process of adding these new instances to the load balancer as they're brought on and as they're taken off. Mm-hmm. So those types of tools. I mentioned RDS, the Amazon's relational database service. So thinking about the first rule of AWS Fight Club, you always want to use a managed service versus a non-managed service. Right. RDS automates that process for us of failing over. So we get some notification that our primary database has failed. AWS just handles that failover for us. Mm-hmm. Those types of tools are ones that we really want to use in this environment and automate as much of this process. When we still want to send out notifications that these problems are occurring because we want to look at them over time and see if we can see patterns. But for the most part, we want the mitigation to happen automatically.
Okay. Okay.
Another place that we often provide guidance and recommendations to customers is around the use of CI/CD tools, so continuous integration and continuous deployment. We want to automate that as well to the extent possible. We want to use whatever tools that you're currently using. Some people are using tools like Bamboo or Jenkins or other open source tools, or they can use tools provided by AWS like Code Pipeline, which allows you to move your application through various stages in your environment, from a development environment to a QA environment to a staging environment and ultimately out to production in an automated fashion, or use Code Deploy, which allows you to make updates very dynamically to your existing code, as opposed to SSHing into an instance and getting the latest from GitHub manually. Once you go beyond 1 or 2 instances that are actually running, that doesn't work very well, and it's again prone to failure. So any type of automation we can add to the system is good. Anytime we can get our people out of the picture and fingers on keyboards, we can remove that reduce the margin for error.
Yeah, that makes sense, and that's generally a good place to apply people's time. Like, I imagine if I work in an organization, I'm going to be much more fulfilled figuring out how to invest my time in building automation as opposed to investing my time at 3 a.m.
Right.
Looking at Apache modules or something mundane. So yeah, no, absolutely. Let me see. So okay, so we not only is AWS providing constructs for operating and the ongoing delivery of software to users, it actually now has tools that are helping influence the way people write and deploy software as well, and which is great. That's awesome. And then and let me take a pause here. A couple things. We got about 20 minutes left, so I want to remind folks that a lot of the discussion we're having today is oriented around ideas that are covered in the white paper that are available for download through the form that you see right next to the window that you're watching this through. So please take the time to do that. There's a lot more stuff there to unearth if you take the time to read the document. It's pretty good. And then the other thing is that if there's live viewers that have any questions from the conversation we've had so far, I just want to remind you that we do have the Q&A feature. So if you want to ask a question to Jerry, who's clearly knowledgeable on this stuff, please do take the time and submit something, and we'll make sure we answer before we wrap up today. So thanks for that commercial break. So jumping back in, I think I left out one piece of the discussion, which is, with our reference application, right? Like how does an application automate and recover? We've talked about the big picture around automation, but like what types of things would this app do in a perfect world where we've built it right?
So the application, it needs to start developing some awareness of what's going on around it, and it needs to be able to react to behaviors that it's seeing, and a lot of times that comes just in the form of, oftentimes as a developer, we're writing code, we're making a call out to a database, and that's it. It's either successful or it's not, and we're failing, we're propagating an exception back up the stack. Ultimately, what the user sees is a blank page, and so we want to prevent that from happening. Again, going back to failing with style, we want to do this gracefully. And so at the application level, what you really want to start doing is thinking about what are the potential failure modes? What am I going to do if I experience a timeout when trying to connect to the database?
Yeah.
How often do I retry? What can I do to minimize the impact to the end user? So here's a good example of this. So in our reference application, we have, say, it's a recommendations engine. So user logs in, they're going to order food. It automatically knows what they ordered in the past, what their friends have ordered, and so it's likely to make recommendations. Hey, your friends tried this, you should try it too, that sort of thing. You see very similar things on Amazon, for example. In the application itself, say for example, it makes a call to another downstream service, the recommendation is this information, and it experiences a timeout. What is it supposed to do? Well, you should have other strategies in place to say, okay, if I can't reach the database, what should I do? Maybe I should just return some default recommendations.
Sure.
Maybe we just have some static recommendations that are available to the user. If ultimately, if that fails, how important is this particular subsystem? Should my entire system fail because this one didn't? And in this case, this is entirely optional, that the system could continue going on without it. But just keeping those things in mind. Number one, failing fast. So as soon as we aren't paying attention and database connections, all of a sudden our systems can be clogged up with these failures and completely overwhelmed. So understanding very quickly how to fail fast, having fallback strategies in place. So if we do experience a failure here, is there a fallback? Is there something else we can do? Can we return some cached information, for example? Maybe it's stale. Maybe we always cache yesterday's information. Or can we return just some static information, some general information to the user?
Right.
Or can we simply cut out that non-essential feature, period? So in this case, it's like going onto Amazon and buying something. If you ever see recommendations, those aren't absolutely necessary for you to buy something, but they are nice to have. And so actually Amazon does this very same thing where those types of features, if there's some problem with the downstream service, you'll see degraded operation or no information at all there. So those are really the, just being more aware, being more reactive to problems, and so defensively coding your application to take advantage of those features.
That makes sense. So it's just a natural progression of the idea of exception handling. Like, don't puke on the user at all costs. Like, display something, right? But never like a whatever the error code is. Like, so yeah, that makes sense. But now we're doing it with services, right? And I mean, you can think about it in the terms of failing gracefully. If you do have a degraded system, like in this case,
for a recommendations engine, returning stale data to the end user, the system is still operating correctly. They're not really seeing anything different, and so it can be very transparently done to the end user.
That makes sense. Yeah. Okay. Okay. Great. Well, so we have covered general fault tolerance concepts. We've talked about infrastructure resilience or resilience native to the infrastructure platform with Amazon. We've talked about automation, right, and how one takes advantage of. So if you're receiving events from like CloudWatch alarms or just native infrastructure tools, and you now have to respond to them, we've talked about strategies for automating a response. In the time that we've had with customers that you've had yourself, but also in the time that we've been operating the FOSS program here at Rackspace, are there any other interesting strategies you've come across that are worth sharing to our viewers for dealing with this kind of stuff?
Yeah. So I mean, in general, think about this from day one. It's not something to think about after a failure has occurred. I mean, obviously that's going to happen if you haven't thought about it ahead of time. But you're better off thinking about this ahead of time. And honestly, that's part of my role in working with customers is, okay, what do you do? What's your strategy when you can't connect to the database? If you can't get cached values, what are you going to be doing in this case? Are you configured correctly to use multiple availability zones in this environment? And so that's really where a lot of the value up front comes in the FOSS program, is when solutions architects like myself, we engage with customers. Those are the types of questions we're asking them. We want them to be fault tolerant. Number one, for their sake, so they don't have to deal with faults and errors and issues. And then from our perspective, from a supportability perspective, having an application that's fault tolerant means less support overhead, both for us and for the customer. So we want to make sure it's a win-win for everybody to do this.
Yeah.
So thinking about it from day one, and then at some point thinking about your application a little bit differently, and maybe thinking about different database types, for example. So a lot of times we'll go directly to a relational database like MySQL or SQL Server. There are other alternatives around there, the NoSQL databases that are available that can provide highly performant data stores for you, perhaps with a little that aren't quite as consistent as a relational database. Think about ways that you can utilize those, because they allow you a lot of flexibility in your application. So if for example, say you were doing even the recommendations engine doesn't need to be as up to date as do you actually need to make a database call to get recommendations for a particular user, or can that information be cached somewhere?
Yeah.
So thinking about different ways of building out your architecture to take advantage of different services and features. Using queuing, for example, is a great example. Decoupling your application components one from another so that they can vary independently, so that they can scale independent of one another, and that they can change the implementation.
Right.
Also thinking about item potency, different ways of handling requests. So these are a lot of things that we talk with customers about and that we see from them on a day-to-day basis. Those are all very common themes. The other one too was just stateless and stateful applications, making sure we identify where state in the application is held, and where we can move it to make our application more fault tolerant and more resilient.
Excellent. Thanks for sharing that. Somebody just knocked on my door, so hopefully they go away when we finish up the last 10 minutes of the show. Let's see. Well, okay. So we've covered all the things we showed up to talk about today. So that's good news, and we did it under time. So let me just check something real quick. I'll go ahead and give last call for anyone who's watching today to submit a question if you have one. But I think then what we should probably do while we see if anyone has a question is just do a quick recap, like a thought or two on each of the three kind of areas. So is there anything that you want the viewers today to to walk away with and have burned into their memory as it relates to, the topic of fault tolerance in general on Amazon Web Services?
Yeah, I think it's worth saying again that number one, everything is going to fail at some point. Something is going to happen, and planning for that from day one will benefit you and your customers. You don't necessarily have to do something about it, but having a strategy for that, whether that be automation or redundancy, at least have that thought in your mind, because at some point you will have to deal with it, and it may not be a priority today, but as your business grows and your customer base grows and demand grows, it will come up.
Yeah. We see this all the time with our customers. We have a customer that wrote an application. It began its life maybe even almost a decade ago under different conditions, and different technology was available. And they grew, and things are great, and then they get acquired, right? And now this property is getting like 5x, 6x the demand, because they're having this bigger company like pushing a bunch of traffic or business through their channel, right? And now they're like, oh God, now what, right? And so that's a very common pattern. Or just folks that just suddenly, due to the whims of society, become really hot out of nowhere, right? And they're now forced with scaling challenges that push the limits of their old world architecture and their needs for availability, right? So I will stand behind those comments, because we see it all the time with our customers today. On the topic of just core infrastructure redundancy in AWS, the features that are made available, anything you want the viewers to walk away with, make sure they don't forget?
The first rule of AWS Fight Club is always use managed AWS services when you can. So if you need memcached or you need Redis in your application, use Elasticache.
Okay.
And allow AWS to manage that redundancy and high availability for you, so you don't need to. Spend your time where it's important, not where someone else will do the heavy lifting for you.
There's no money to be made in setting up Red Hat clustering services for memcache processes. Nobody ever got rich doing that, Jerry. Not to my knowledge. Maybe AWS. And then recap your thoughts on automating responses for availability situations, automating responses to events.
Anytime you have a manual process, again, there is an option. There's always room for an error to occur, and so any place that you can utilize automated features, again, going back to AWS specifically, if you can automate redundancy, if you can automate failover, if you can automate recovery, use those services where you can. Any place where you find that you're having to go in and manually do something, always be thinking about what you could do to automate that process. And again, these are specific to AWS, but just in general, if we want to have a really fault-tolerant system, one that's able to respond very quickly and dynamically to changes in the system, it has to be automated. That having a manual step in there really doesn't work for us.
Very cool. Well, Jerry, thank you so much for your time today. I really appreciate it, and I would love to have you back someday, so maybe we'll work together again soon.
Hey, Doug, thank you. I appreciate the time and the opportunity to come speak with you and with all your listeners and watchers. Thank you very much.
You bet. And thanks to the viewers that joined live today and those that end up watching on demand. Just a reminder that you can go to rackspace.com/deepdive to find both the schedule for future shows as well as the catalog for shows we've run previously, and also download all the associated assets. So do take a look at that when you get a chance. And also as well, feel free to use the social buttons to share amongst your friends and followers, and also use that to let us know if there's anything that we did great or anything that we weren't so great at and how we can get better. Until next time, thanks everyone. We'll see you next week.